Today we are going to be talking about graphing sine and cosine functions. By the end of this video, you should be able to graph sine and cosine functions, changing only the amplitude and period, and you should be able to label the appropriate scales for the x and y axis. When we graph our sine and cosine curves, we are going to use 5 key points in radians. So if this is our unit circle, we are going to use the angles on the unit circle that have integer coordinates. That means we are only going to use the coordinates that are easy to graph. First we have 0, then pi over 2, pi, 3 pi over 2, and 2 pi. The coordinates of these points are 1, 0, 0, 1, negative 1, 0, 0, negative 1, and back to 1, 0. Remember that cosine of an angle is the x value and sine of an angle is the y value. So let's take a look at the graph of a sine curve. When we are graphing the sine function, remember we are looking at the y values for each of these angles. So if we have theta and sine of theta, we said on the previous slide that we are going to be using the angles 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember that sine is the y value for the coordinates of these angles. So we have 0, 1, 0, negative 1, and 0. Now I'm going to show you the standard way to label your axes when we graph trig functions. We are going to say that each block vertically is 1/2, so that makes this 1 here and this 2 here, negative 1 and negative 2. Along the x-axis, we are going to count by pi over 4. It's a little annoying to have to write pi over 4, pi over 2, 3 pi over 4, and pi for every mark on the x-axis, so I'm just going to write multiples of pi. So if I have pi over 4 for each mark, that means that every 4 marks is pi. So this would be 2 pi, and this would be 3 pi. We can also go to the negative, negative pi, and then negative 2 pi would be off our graph. Now we just plot these values. For an angle of 0 radians, our sine value is 0. When our angle is pi over 2, which would be here, the sine value is positive 1. For an angle of pi, the y value is 0. For an angle of 3 pi over 2, the sine of that angle is negative 1, so 3 pi over 2 is here. An angle of 2 pi, our sine is 0. So this is what we call one period of the sine curve. We can continue around the unit circle. If we go to 5 pi over 2, that is a coterminal angle with pi over 2, so that means they have the same sine value. 3 pi is a coterminal angle with pi, so they have the same sine value. We can also go the other way. If we go to negative pi over 2, that is coterminal angle with 3 pi over 2, etc. And the pattern continues. So when we connect these points, we end up with a curve. And this pattern will continue forever. Generally, the part of the sine curve that we are most interested in is the part between 0 and 2 pi. So that would be this portion of the curve. Now let's take a look at the domain and range of this function. Since we said that this pattern can continue on forever, both to the left and the right, that means our domain is all real numbers or negative infinity to infinity. Our range, if you look here, the lowest that the graph goes is -1, the highest that the graph goes is +1. So our range is -1 to +1. Let's go on to the cosine function. For the cosine curve, we're going to do a similar process. We're going to look at our chart first for the angle and the cosine values of those angles. So let's look at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember that cosine is the x-coordinate of that angle. So cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is +1. We are going to label our axes the same way that we did on the previous graph. On the y-axis, we are going to count by 1/2. That means we have 1, 2, -1, and -2. On the x-axis, we are going to count by pi over 4, but I'm only going to mark multiples of pi. And then I just graph the values that we have in this table. For theta equal to 0, the cosine of that would be +1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. Just like with the sine curve, this pattern will continue if we go around the circle more times. And then we can just connect these points to form our curve. Again, the part of the graph that we are going to focus on is between the angles of 0 and 2 pi radians, which is this section of our graph. If we take a look at the domain and range of this function, since this graph can continue forever, our domain is all real numbers, or -infinity to +infinity, and our range, again, is going to be -1 to +1. Before we continue, there are a few things that we need to define. First, earlier I used the word periodic, or period. A periodic function is a function that repeats. one cycle is called a period. The period for the sine and cosine functions are both 2 pi. This means that every 2 pi radians, the graph or the function begin to repeat. So let's go back. If we start here, our sine curve goes up, then it goes down, and then it goes back up again. And only after we go through 2 pi radians does it start to repeat. Same thing with our cosine function. We start at +1, we go down to -1, back up to +1. That takes 2 pi radians, and then the pattern repeats. So a period or a full cycle of either of those graphs is 2 pi radians. Here we have standard form for a trig function, and it doesn't matter if this is sine or cosine, it's the same format. A is going to be our amplitude, and when we talk about amplitude, we want the absolute value of A. This tells us the height of our graph. Today, we're only going to worry about A and B. We'll worry about C and D later. B affects the period of the graph. Since for the regular sine and cosine curves, the period is 2 pi, that means that the period of any sine or cosine function will be 2 pi divided by b. One thing that's going to be helpful as we're trying to graph is to look at the quarter period, which I'm going to abbreviate as QP. This is just the period divided by 4. And that'll tell us where our key points are going to be. We'll see that when we get to an example in a few minutes. First, let's take a look at how the amplitude affects the graph of our functions. Here we have y equals 3 cosine of x. First, let's write down what our amplitude, period, and quarter period are. Our amplitude is 3. Our period is 2 pi divided by b. B is the coefficient of x, which is 1, so our period is just 2 pi. And then our quarter period is the period divided by 4, which would be 2 pi over 4, which simplifies to pi over 2. So, the only thing that is different about this function is that the amplitude is 3. So instead of having a range of -1 to +1, like our original cosine function, this graph is going to have a range of -3 to +3. Now, I'm going to label the axes the same way that I did on the previous examples, but I need to go to 3 on the y-axis, which you can see will be off this graph. The x-axis will not change in the way that I label it. So I know that this is a cosine function. So if I go back to my original cosine curve, I'm going to start at the top of this curve. But instead of the top of the curve being at 1, the top of the curve is going to be at 3. The rest of the pattern does not change. It just gets stretched vertically. One of the ways that you can remember how to graph a sine curve or a cosine curve, for cosine, you think high, 0, low, 0, high. So if I connect these points, that will be one period of the cosine curve. So there is one cycle of this graph. We could continue the pattern and have multiple periods, but that's not really necessary. If we take a look at the domain and the range, we could continue this pattern forever. So our domain is negative infinity to infinity. Our range goes from negative 3 to positive 3. Let's take a look at another example. Here we have y equals 1/2 cosine of x. So again, we have a cosine curve, so our graph is going to be high, 0, low, 0, high. This time our amplitude is 1/2. Our period is 2 pi divided by b. Again, here b is 1, so our period is just 2 pi. And our quarter period is the period divided by 4, which is pi over 2. I'm going to go ahead and label the axes the way that I have for the other problems. Now this time, since my amplitude is 1/2, instead of going all the way up to positive 1 and all the way down to negative 1, I'm only going up to positive 1/2. Then the next one is 0. The next one is low, which will be negative 1/2. 0, positive 1/2. And I just connect these points to create my curve. Just to note, remember that these are curves. Your graphs should not look like a V, they should be curved. Since we can continue this pattern forever and do multiple cycles of the graph, our domain is all real numbers, or negative infinity to positive infinity, and our range is going to be negative 1/2 to positive 1/2. So you can see that the amplitude affects how tall our graph is going to be. Next, we have y equals negative 2 cosine of x. Remember that our amplitude is always the absolute value of a, so our amplitude is positive 2, but the fact that it is a negative will change how our graph looks. The period is 2 pi divided by b, which is just 2 pi. And the quarter period is 2 pi divided by 4, or pi over 2. Again, I'm going to go ahead and label my axes. Again, I have a cosine function, so usually my graph would be high, 0, low, 0, high. Since a is negative, that is going to switch my graph upside down. So I'm actually going to have low, 0, high, 0, low. since the amplitude is 2, that means my graph will go up to positive 2 and down to negative 2. But I'm going to start the low point of the curve. So I'm going to start at negative 2. Then I go 1/4 period, which is pi over 2, to put my next key point. So since I have a negative a value, I have low, 0, high, 0, low. Then I connect the points to form the curve. And there we have one period of this function. Our domain, again, is all real numbers because we could continue this pattern forever. And our range is -2 to +2. Now, let's take a look at what b does to our graph. Here we have y equals sine of 2x. Our amplitude is 1. B is 2, so our period is going to be 2 pi divided by 2, which is just pi. Our quarter period is going to be the period, which is pi, divided by 4, so pi over 4. I'm going to label my axes the way I have for the other problems. Now, since our period is pi, that means I need to complete a full cycle of the sine curve by the time I get to pi. Since we have a sine curve, a trick to remembering how the graph looks, you start at 0, then you go high, 0, low, 0. Instead of having the regular sine curve that takes 2 pi to cycle, I'm going to condense that so that the cycle happens in pi radians. Here's where the quarter period is helpful. I should have a key point every pi over 4 radians. Since each line is pi over 4, that means I should have a point on each of these lines. So I'm going to start at 0, go high. Since our amplitude is 1, that means we're only going up to 1. 0, low, 0. So 0, low would be -1, 0. Then I connect the points. So I have completed one cycle or one period of this function in pi radians. Again, I could continue this pattern forever. So my domain is -infinity to infinity. My range is -1 to +1. Next, let's look at y equals sine of 1/2 x. My amplitude is 1. Our period is 2 pi divided by b, which is 1/2. Since we're dividing by a fraction, that's the same as multiplying by the reciprocal. So we get that our period is 4 pi. The quarter period will be 4 pi divided by 4, which is pi. I'm going to label the axes like I have for all of the other problems. But I have a problem here. The period is going to be 4 pi, which means that it will take 4 pi radians to complete the cycle once. So I need to extend my graph. Since we have a sine curve, we're going to go 0, high, 0, low, 0. My quarter period is pi, which means that I'm only going to put a point at every multiple of pi. So if I start at 0, my next key point, the high point, should not be until pi. So that'll be the high point. Then 0 will be at the next multiple of pi, which is 2 pi. Then the next key point, which is the low point, will be at the next multiple of pi. And our last key point will be at 4 pi. So you can see that we have stretched out the length of our graph. So let's connect the points. And there we have one period of our sine curve. Since this could repeat forever, our domain is still negative infinity to infinity, and our range is -1 to +1. So you can see here that when we have a larger value for b, that condenses our graph, but when we have a smaller value for b, it extends our graph. Lastly, we have y equals sine of 3x. Our amplitude is 1. The period will be 2 pi divided by b, which is 3. And our quarter period will be 2 pi over 3 divided by 4. Dividing by 4 is the same thing as multiplying by 1/4. So we have 2 pi over 12, which simplifies to pi over 6. That means that we should have a key point at every pi over 6. Now, don't write this down yet. I'm going to label the graph the way that we have for the other problems, and I'm going to show you an issue. Since the period is 2 pi over 3, that means that we should complete one cycle in 2 pi over 3 radians. Well, if each mark is pi over 4, we complete pi radians in 4 marks. I don't know where 2 pi over 3 is. So, for the most part, I want you to label the graphs like this so that you can see what is changing with the graphs. But if your period has a denominator of 3 or 6, I will allow you to label your axes differently. I will allow you to count by pi over 6. So I'm going to change how I've labeled my x-axis. If each line is pi over 6, that means that pi is going to be the 6th line. So 2 pi is the 12th line. and negative pi would be 6 marks in the other direction. Our quarter period is pi over 6, which means that we should have a point every pi over 6, which in this case is at every line. We have a sine function again, so we're going to go 0, high, 0, low, 0. And our amplitude is 1, so we are going up to positive 1 and down to negative 1. So I'm going to go 1 quarter period, which is pi over 6. That's where my next point is. Then 1 quarter period for my 0 point, another quarter period for the low point, and another quarter period to get back to 0. So if 6 marks are 1 pi, you can see that we went 2/3 of the distance for 1 period of the graph. So we have our sine curve there. Since this can be repeated, our domain is negative infinity to infinity. Since our amplitude is still 1, the range is negative 1 to positive 1. Remember that this is an exception in terms of the way that we label our x-axes. You can only count by pi over 6 if the period has a denominator of 3 or 6. Otherwise, you should be counting by pi over 4 as we did on all of the previous graphs.